on how to plan for patching in Exadata, followed by patching each component of Exadata using demos. This will be a 90-minute session.
Today, I'll be taking you through the planning aspects of patching and Exadata, including the patching methods available, components to be patched, what are the considerations to be made while deciding the patch, how to find the documents and make sense of them. Once we are done with the patch planning, we will jump into the main part of the session today, which will include demonstrations covering patching a self-storage server, compute servers, DOM0 servers, and the InfiniBand switches. We will finally look at how to roll back some of the patches if required. Some of you might already be patching your Exadata today using Oracle Platinum Team, which is a great free all-included service from Oracle. Platinum patches every component of your Exadata. Or you probably might already be doing it yourself, either using OEM, Oracle's fleet management, or the automated patching tools like the Patch Manager, which we will be discussing today. Oracle provides the built-in automated tool to patch all the infrastructure components of an Exadata called the Patch Manager. Patching in Exadata via Patch Manager is what we will be concentrating mainly on today. Though Platinum patches the Exadata for you once a quarter, there might be times when you would want to do it yourself. Using Patch Manager, you can achieve it. Every other patching mechanism mentioned here uses Patch Manager and/or its components on the back end. Oracle releases patches for Exadata in two sets. One is the quarterly full stack bundle, as the name suggests, which is released once a quarter, and will have the infrastructure patches, grid, and database home patch within it. The infrastructure patch, called the ESS patch, is released on a monthly cycle for systems patching. The MOS document 888828.1 is the most important document for all things Exadata, from getting the installation assistant, finding out vulnerabilities, determining patches, downloading patches, etc. 888828 also provides you with the information on any critical issues that are found on an Exadata, covers security-related guidance notices. If you have any vulnerabilities that come up, like the Spectre meltdown, all those things will be mentioned within the 888828 document. It will also address any critical issues in the grid infrastructure or database versions. So let's take a look at what are the components that needs to be patched in an Exadata. The storage servers, the DB servers, and the internal network switches together form the basic infrastructure components. The compute or the DB server can be virtualized to host multiple VMs and VM clusters. These are the components that we will be patching today using the Patch Manager. The grid infrastructure and the database home, which sits within the virtual nodes, are not part of the infrastructure patching, and we will not be covering them today. So what is Patch Manager? Patch Manager is the automated tooling provided with every Exadata to simplify the ESS update process. Every ESS patch comes with its own Patch Manager bundle within the patch. The Patch Manager for the self-storage servers, compute servers, and the internal fabric switch, which could either be the InfiniBand or the RAC, depending on which version of Exadata you have, are different and is provided within their respective patches. Patch Manager has a requirement that it has to be run from an Oracle Enterprise Linux server. It does not matter if you're running it from the Exadata you're patching, a different Exadata in your environment, or a different OEL server. A single invocation of Patch Manager can complete the patching for a set of components like a full rack of Exadata storage servers, multi-rack of Exadata storage servers, etc. Patch Manager can either be run in a rolling or a parallel fashion. To be able to run in a parallel fashion, which is the default method, the entire grid and database stack has to be shut down. If you as a customer cannot afford a downtime, it's best to run it in a rolling fashion, by mentioning the rolling option within the Patch Manager tool. Patch Manager has a very simple syntax as we see here. You invoke Patch Manager by providing it a component list file. This file contains the names of the servers against which it needs to perform the action mentioned. There is a set of required arguments that needs to be mentioned, like whether you want to do a prereq or you want to really patch the server. And then you have additional optional arguments. We will take a deeper look at these Patch Manager options later during the demos. Let's now look at the MOS document 888828, which we touched upon briefly a few minutes ago. Searching the doc number in MOS ends up with this page. You can bookmark this page by clicking on the star just before the document name. This document lists the software patches and releases for Exadata database machine. It includes versions for both the database and storage servers of an Oracle Exadata database machine. Exadata versions 11 and above are covered within this document. So here, I want you to note that the ESS version and the grid and database home versions are different. Point in case, ESS 20 is not database 20C. Neither is ESS 19 same as database 19C. When we mention ESS, we are strictly talking about the Exadata storage software and not the database or the grid version. There is a lot of confusion among folks who use Exadata today with respect to this, and I want this to be very clear. As you scroll down further, you will find the section covering all the database releases. Here, we see the latest ESS patches available, latest quarterly full stack patches that are available, latest database grid infrastructure patches that are available. If you click on any of these, it would take you to that section within the document which would talk about that particular patch. Today, we have 4 viable paths for patching an Exadata storage server. Let's look at it in a bit more in detail. While talking to many customers, I have seen that there is a tendency to assume that, as an example, ESS 20.1.0.0 is the latest patch when compared to, say, an 18.1.30.0.0. This is not necessarily true, and you need to keep that in mind. 20.1.2.0 is the latest patch today in the 20.x path, while 18.1.30.0.0 is the latest patch in the 18.x path. They both are distinct paths, and customers can continue going on each of the paths that they have chosen or upgrade from one path to another during the patch planning process. However, Oracle always recommends that you be on the latest patch on the latest path. So you may ask me, how are they different then? So let's take a look at each of them. ESS 18.x provides you with OEL 6.x with UEK version 4. All Exadata X7 and above should minimally have ESS 18x. Any customer with hardware X7 or below and want to remain at OEL 6 must choose this path as their patch option. ESS 19.2x is the first patch released with OEL 7. However, with UEK 4, this is also the minimum version of patch supported on an X8. So if you're a customer with an X8 Exadata or below and need to be on OEL 7, but want to remain on UEK 4, then ESS 19.2.x is the path for you. So what happens if you want to have OEL 7 with UEK 5? That leads you to ESS 19.3.x. 19.3.x path is the minimum version that's supported on an Exadata X8M. So today, if you have an X8M, the minimum version running on that would be a 19.3.1 or above. So 19.3.x also introduced KVM and RAC. KVM is the hypervisor for a virtualization engine from X8M onwards. The X8 and the X7s or before were using Xen as their virtualization machine. I had this one customer recently ask me if they upgrade to 19.3 on an X7, would they be able to make use of KVM or RAC? The answer to that is a clear no. KVM and RAC are available on Exadata X8M and above only. If you upgrade to 19.3 or above on an older Exadata other than X8M, you will still be running Xen and InfiniBand and not KVM or RAC. Exadata 20.x is our latest ESS path, which was released in June 2020. 20.x provides you with OEL7 with UEK5, but with additional enhancements built into it. It is also currently the recommended version for your X8M machine. ESS 20.1.0.0, which was the first iteration of the 20.x path, is the patch we will be applying today during our demos. Let's now take a deeper look at ESS 20.1. The ESS bundle 20.1 consists of 4 main patches: the storage server, the storage server software, the InfiniBand or the RDMA switch software, the DOM-U bare metal KVM ISO image, and the Xen DOM0 ISO image. If you're patching the X8M or you're not making use of any virtualization on your current Exadata, then you would not need the 4th patch, which is the Xen DOM0 patch. Every patch comes with its own README file, which describes all the do's and don'ts for a patch. We will take a look at that in a moment. Every patch would also have the minimal requirements mentioned. As an example over here, for the 20.1.0.0, we are patching today, we have specific OEM requirement mentioned. Let's take a look now at what are those OEM requirements. Here we see that for either ESS 19.3.x or 20.1.x, we need OEM plugin version to be at minimum 13.4.1.0 and that the Exadata target type must be 13C. These are the type of prerequisites you need to meet ideally before you begin patching. Some prerequisites can also be met at the completion of patching as a part of the post-patching event. A point to note is that these requirements may be different for different patches and must always be identified and accounted for during the patch planning process. So there might be requirements of a OEM like we saw over here. There might be requirements of a different grid patch or database patch that needs to go in, and we need to take into cognizance before the patching is done. So let's now look at the ESS README we found along with our patch description in the 88828 document above. Clicking on the README brings me to this page. The README will provide you with a review of what's new with this patch. You can click on the link and read all the new features that come with the patch. Here, I'm not going to spend a lot of time on what are the new features. You can take a look. I'm just mentioning where we find them. The README also importantly provides you with what version of database, home, and grid are supported. You need to make sure you are at minimum versions mentioned for both the database and the grid. If not, you'll be required to either go to a lower ESS patch where your current grid and database home are supported, or ideally upgrade your grid and database home before you end up patching the ESS software. Scrolling down the README, we find links to all the patches that needs to be downloaded. Here, we have additional ISO image that can be downloaded. These ISO images are used to recover a machine during a failure for diagnostics, to reimage a server, use as a PX image for booting, etc. For the purpose of this webinar, we will only concentrate on these 4 patches, which are the software and image files used for upgrades. Well, now that we have discussed the patch planning process, let's look at the environment we have today to execute the patching. Here today we have an Exadata X62 half rack, which has 4 compute nodes, 2 InfiniBand switches, and 7 cell storage servers. The compute nodes are virtualized and host multiple VMs, forming 5 virtual clusters. For this demo, we will be patching the cluster number 4 that consists of VMs exadbcpatchmulti VM04 running on host exa14db03, and the second VM exadbc04 VM04 running on the physical host exa14db04. We will also be patching the 7 storage servers and the 2 InfiniBand switches that come along with a half-rack Exadata. For the sake of saving time, I have already copied over all the files to the Exadata, and I've also set up SSH user equivalents for the root user from exa14db03 and exa14db01 to all the VMs and the storage server. DCLI-L root G cell nodes-K is an easy way to set up user equivalents if you have not set up. So here, I also check that the user equivalence is set up by executing the hostname command. Let's now jump into the demo session, where we will first begin to patch our 7 Exadata storage servers in a rolling fashion. Let me start this demo by introducing you to a few useful commands that we would need during this patching event. DMID code can be used to determine the version of Exadata hardware that you're running. Keep in mind, this is applicable only on the server you're running. So if you have done expansions with newer hardware, this version will differ on each server and you'll have to run it over there. As we see, the Exadata version of the hardware over here is the X62 as we expected. Image info is another interesting command. Image info gives you what is the current version of the Exadata storage software that is installed. Here we see the current image version being 18.1.8.0.0, and the image status is success. We also see that the image was activated on 29th November of 2018, and that the image currently runs on the LVDB-sys3 partition. The image status being success is important to note always once the patching is completed to make sure that everything is right with the patching. Image history provides us with all the versions of ESS ever installed on the node where it is run. Here we see that only ESS 18.1.8.0.0 has ever been installed. The image mode fresh tells us that this is a version installed during the initial build of the Exadata. Once we upgrade this to 20.1.0.0 today and run the image history again, we will see 20.1.0 being the display with image status success, and the image mode will be patch instead of fresh. And it will also display 18.1.8.0 below that as the patch that was installed before. DCLI is another tool provided on the Exadata to facilitate you to run commands parallelly across multiple nodes of an Exadata or multiple Exadatas. Here, DCLI-L root-G cell_nodes followed by the command is the way to run DCLI. In this command, the hostname -I is the command executed. Cell_nodes is the group file that contains the name of all the hosts against which the DCLI is expected to run. In the second command, I just changed the command host-name with date. So it again ran the same DCLI with date instead of hostname across all the 7 cell servers, which are placed in the cell_nodes file. Let's take a look at what the cell_nodes file contains here. As I mentioned, this contains the list of all the 7 nodes belonging to this half-rack Exadata and tells DCLI against which the command date or the hostname -I has to be run. So let's now look at another important command, the xm list command. It basically lists all the virtual machines that are created on the compute nodes of the Exadata. In this case, we see that DOM0, which is the host node for the virtuals, uses 4 OCPUs and about 8 GB of memory. The other 2 VMs that are running on this are Exadata 14 DB03 VM01 with 32 vCPUs and about 26 GB of RAM, and Exadata 14 DB03 VM04 with 8 CPUs and around 13 GB of RAM. This Exadata 14 DB03 VM04 is what we will be patching today for our patch cycle. Let's now jump into patching the Exadata. Here, I have already copied the 4 patch onto this DOM0 machine. P30259791 is the patch that has to be applied to the cell servers. The first order of action over here is to extract the zipped file. The zip file consists of an ISO within it, which will be used as the ESS 20.1 image for patching the cell storage service. This will create a folder called patch_20.1.0.0, within which we should have the patch manager utility used to patch the servers. Point to note here is though the utility to patch compute servers and IB switches, they are the same patch manager, they are different, and each of those patches have their own patch manager that need to be used. You cannot use the storage patch manager to patch the database servers and vice versa. We now copy the cell_nodes file that we had created into the patch.20.1 folder that the zip file created, so that we do not have to give the full path for the cell nodes every time during our patching event. I'm making sure that the cell nodes contain all the cell servers over here. So let's now look at the options that are available with the patch manager command. We see options like patch, rollback, cleanup, ignore alerts, reset, and rolling mentioned over there. If for any reason you have a hardware alert on the storage server, but you have to still go ahead with the patching, you can use the ignore alert option, though it's never advised to go ahead with patching until all the errors are fixed. Rolling, as the name suggests, lets the patch manager know that the cells have to be patched in a rolling manner. If this option is not mentioned, the patch manager assumes you want to do the patching parallelly and start the patching on all servers if the prerequisites are met. The first time that the storage servers are updated to a specific patch set, the patch manager option reset force must be used before a cleanup option is executed. The cleanup option, as the name suggests, cleans up any leftover patch files and temporary content on all storage servers from possible previous patching events. Here, we execute both the reset force, because we are patching this for the first time, and the cleanup option. So we see that the force cleanup is, the reset force is completed, and now we execute the force cleanup or the cleanup option. So we have the cleanup option successfully completed. We are now ready to run the patch prereq to make sure there are no hurdles before we can go ahead with the patching. Please note here that I'm using the -- rolling option even for the prereq. If I do not use the rolling option during the prereq, it will perform the prereq for the parallel option by default, assuming that all the DB instances and grid are shut down for the patching event. And since we have not shut down the grid and the database, the prereq would fail. So if you want to patch in a rolling fashion, you should also do your prereq in a rolling fashion. This prereq is expected to take 5 to 15 minutes for completion, depending on how many nodes and issues are currently present on a server. The prereq will check for any hardware or software issues and report accordingly. It will copy the patch over to all the cells that were mentioned in the cell_nodes file that we created, check for available space on the cell servers to make sure the ISO can be extracted for the patching. And if there are any issues, the prereq would fail and intimate us. Okay, the prereq has completed successfully now. Let's take a quick look at all the things it checked. It checked for space and state of cell services. It looked at the Patch Manager plugin and made sure it checked against some of the known bugs, if the patching would be impacted by them. It also checked for user equivalence between this node and all the nodes in the cell_nodes file. It checked for the ASM deactivation outcome. ASM deactivation outcome is basically a test to determine if the cell nodes can be shut down for patching one at a time. If there are any disk failures on the other cell, which are expected to stay up during the rolling patching, and its mirror copy cell is going to be patched, the ASM deactivation outcome becomes a no, and hence the prereq will fail. The ASM deactivation outcome should always be a yes for the prereq to pass. Going ahead, it also checked for the MS services and made sure it's running. It then finally checked for all the storage servers for the images that were installed on it. Patchmanager.log is the log file where this entire patching event would be logged, and patchmanager.stderr is where all the errors will be captured. These are some of the important files Oracle support would ask you if you log a support case if there are any issues during patching. It will also create a log file for each of the cell storage servers being patched here, and we can examine each of them if there is an error during patching. Now that we have successfully completed the prereq, we are ready to patch the cell nodes in a rolling fashion. So for that, we basically just change the command by removing the prereq option and adding the patch option in its place. Even though we have completed a prereq, the patch option will still complete a prereq every time. This is because you could possibly run a prereq a couple of days before the actual event to make sure you have no issues, but there might be a hardware or a bug that has happened between then and when you actually go ahead and patch. So currently we are running the same prereqs that was run previously in the patch cycle. So this patch should take anywhere between 60 to 90 minutes to patch a single cell node because we are doing it in a rolling fashion. So if we have 7 cell nodes, it's expected to take about 7 to 10 hours to patch a half-rack Exadata storage cells in a rolling fashion. If you can afford to take a downtime, you should then consider doing it in parallel where all 7 or how many ever cell servers you have can be patched at the same time. So the decision to patch in parallel or rolling is totally up to you to decide how you would want to do it based on your requirement and flexibility to have your databases down or continue running them up and doing it in a rolling fashion. We have some customers doing rolling exclusively, some doing it in parallel exclusively. Some customers prefer to do their DR in parallel, but production in a rolling fashion with their workloads running during the patching. So the decision to patch in parallel or rolling is completely up to you. Point to note, the ESS patch will not only patch the operating system, but will also take care of any firmware upgrades and the ILOM upgrades on the hardware that is being patched. So here we see that the prereqs are in progress, and it would take a few more minutes to complete them. So here we see that the prerequisites on all cells are marked a success. And now the patch manager is copying all the patches to its respective cells. We now also see that the cell 1 is initiated to be patched in a rolling fashion. Since the patching takes over an hour, as mentioned, from this point, we are going to pause the demo and rejoin at an appropriate point to see what's going on. So there are 5 steps within patching, and we are on the second of the 5 steps on this cell server. So coming back, we see that step 3 of 5 was just completed. It finalized the patch and checked final status on the cells and execute the plug check for patching was also success. So at this point, the patching is totally completed and the cell server is waiting to go for a reboot. During the reboot, the firmware and the ILOM patches also get upgraded. And depending on the number of upgrades that has to happen on the ILOM or on the firmware, there might be multiple reboots that the cell storage server takes. Again, you don't have to do anything to make sure that that goes on. Once you have issued the patch manager command, the patch manager takes care of it across all the cell storage servers that you mentioned within the cell_nodes file. We will pause again here and get back once cell 1 patching is totally complete. Okay, so we can now see that exa14 cell 01, our first cell node in the cell_node file that we created, is successfully patched. At this point, the OS image, the firmware, and the ILOM would be upgraded and on the cell server rebooted. The grid disks were also activated, and any resync of any Delta data that would have happened to its partner disks were resynced. We also see that the cell has gone ahead and the patching has begun on cell 02. Here, we see that we started at 7:55 hours and the first node completed at about 8:41 hours, which is about 46 minutes, or around about what we expected. The time it takes to patch a cell node can vary significantly based on the Delta data that was written to the other 2 copies of the ASM disk during the patching event. If there is a lot of data written during that time, it takes more time to resync the data back to the grid disks which were just patched. This Exadata does not have a lot of workload currently, so the ASM hardly had any resync that needs to be performed. I'm going to pause this demo again now to allow for all the 7 nodes to be patched. Okay, so at this stage, we have 6 storage servers being patched and the 7th is in progress. Looking at how long we have taken, we started at 7:55 as we noted before, and we are at 12:24 hours now. So that's approximately 3.5 hours of patching, and we are still completing the last cell node, Exadata 07. We see that all the 6 cell servers before have been patched successfully without any errors. You need to watch for the success word against each of those cell servers. So over here, we see that cell 07 patching has been completed. It's waiting for its grid disks to be activated and the data to be resynced on the grid disks on cell 07. So this should take a couple of more minutes to complete. On completion of cell 07, our entire patching of the storage cell servers would be completed. So here, at this point, we have all 7 storage servers whose patching has been completed. And the cleanup has also been done successfully. We see that the entire patching event was a success and also gives us the host name of servers that were patched and the image version that we currently are. If you notice before, this was showing 18.1.8 when we ran the pre-checks, and now it's showing 20.1.0.0 to the version that we went as expected. It is always a good practice to make sure manually everything was a success. So over here, I used the DCLI option and checked for the active image version and the active image status. I expect the active image version to be 20.1.1 and the active image status to be success across all the 7-cell storage servers. And here we see that. So this completes the patching of the entire storage cell servers. As you saw, it's basically just one command that you execute using the patch manager utility, which would patch the operating system, the firmware, and the ILOM across all the Exadata storage servers in your Exadata. The blue over here depicts the storage servers. So if it's a half rack, it would only be 7 storage servers. If it's a full rack, it would be 14 storage servers. And if it's elastic rack, you have as many as you have in a rack. And everything can be patched using just one command. Let's now go ahead and take a look at patching the DOM U, or the virtual machine which sits on top of the compute server in an Exadata in our next demo. Exadata 14 DB03 VM04 is the first virtual node of the 2-node cluster that we will be patching today. DBs can be patched one at a time in a rolling fashion. The current exa image running on this is 18.1.8 as we expected. Again, looking at the image history like we did on the cell servers, we see that 18.1.8 is the only image installed on this Exadata. The mode is fresh, being the first image installed, and the image status is success, which is what we want to see. The image 18.1.8.0 provides us with Oracle Enterprise Linux 6.10, while going to 20.1 will take you to OEL 7. These are the type of due diligence you should be performing during the patch planning. If there are requirements for any OEL 7 components, you need to take care of that. The patch manager can shut down the database for you, but as a good practice, I like to shut down the database instance and the grid myself. I already have the database instance shut down here, so I'm going to go ahead and check if my grid is up using the crstat command. I see that it's still running, so I'm going to go ahead and shut down the grid at this point. There you have it. We have the grid already shut down. Another important point to keep in mind during patching a compute node is to check for any NFS shares that might have been mounted for either your backups or any other use case that you might have. Here, I do not have any NFS share. The patch manager would prefer the NFS mount points to be unmounted during the patching. Even though I don't have any NFS share, I would like to make sure that there are no entries made in the HCFS tab, which would bring up an NFS mount point during a reboot. If you have any NFS mount point over here, I would advise you to comment it so that it does not come up during the reboot of the server during the patching event. Any additional tool sets that are installed on your compute nodes are a possible point of contention during patching. It's your responsibility to make sure there is no RPM conflicts that can be introduced during the patching event. The patch manager checks for these conflicts and flags them if any. And you will need to resolve these conflicts before going ahead with the patching. If you do have any additional RPMs installed other than that came with the Exadata, via installing any tools like Autosys, CyberArk, Tivoli, etc., it's advisable you check for the Exadata exact RPM and delete it before you start the patching. The Exadata exact RPM checks for the exact compatibility from when the image was installed and expects it to be the same. Since this is a pretty clean system in the lab, I don't expect to really see any dependency issues here during this session. However, it might be ideal for you to remove the Exadata exact RPM before you go ahead with either the prereq or the real patching. The prereq will still have to pass the minimum RPM check, just not the exact RPM check once you delete the Exadata exact RPM. As we were waiting for the cell servers to be patched, I went ahead and set up Exa14db01, the first DOM0 node on the half rack to have SSH equivalence with our virtual compute node Exadata 14db03 VM04, which we will be patching today. I also copied out the patches to Exa14db01 with the same directory structure we had on Exadata 14db03. These are the two patches which we will need to patch the DOM-U. P21634633 is the patch manager specifically created to patch a DB server, while P30259840 patch is the DOM-U patch that we need to now apply for the virtual Exa14db03 VM04 to be at 20.1. I have also unzipped the DB patch manager bundle, which will create a DB servers underscore patch underscore 20 directory and extract all the files there. This directory will consist of the patch manager that is required to patch the virtual servers. We need to create DB underscore nodes file, like how we had the cell nodes file to patch the cell servers. Here in the DB underscore nodes file, I have Exadata 14 DB03 VM04, which is the node I am planning to patch today. We will now make sure SSH equivalence is set up before we go ahead and run the prereq. So running a DCLI with the host name should give me the host name for that server. Let's now look at the patch manager command that we need to run on a DB server and its options. The options we are using here are -db nodes and supplying it with the db underscore nodes file we just created, which would have the name of the server against which the patch manager should be run. We do a -pre check because we need to perform a pre-check before we can patch. ISO underscore repo is the option where you provide the location of the DOM-U patch that we just downloaded. In our case, it is under /temp/ESS20_1 followed by the patch name, including the .zip. Keep in mind that you should not unzip this file. The -target version should mention the target ESS that you are going to, which in this case is 20.1.0.0.200616. And I also used the no modify at prereq option. This is an important option since you have the ability to run this prereq days before the real patching event and make sure everything is set. By mentioning this option, no changes will be done on your DB node. --skip underscore GI underscore DB validation is an option used when you do not want the patch manager to check for the GI and DB compatibility. Unfortunately, on this machine for this demo, I have an older version of Grid running, but I wanted to show you how to patch 20.1. So I am forced to use the -skip GI DB validation. I advise that you never use that. This prereq should take about 5 minutes to complete. It's currently checking for SSH equivalence on Exa14db03 VM04. The prereq is completed at this time. It checked for the user equivalence, it checked for free space, and it checked for the current image that is running on the Exadata. Again, the logs will be found at patchmanager.log file, and there will be db update hostname underscore db update.log created for any of the logs that might be generated. So now that our prereqs are clean, let's go ahead and patch the DB node. We do not need the no modify at prereq option anymore since we're going to patch the server now. We also have to change the prereq option to the upgrade option. So here I mentioned upgrade and hit enter basically at this point. Here we go. As we see, it's going to go ahead and again perform all the pre-checks before proceeding with the patching. An important point to note is that the patch manager utility during the patching event on completion of the pre-check will always first back up the operating system image onto a secondary sys volume before the patching begins. Let's look at the compute node where the primary operating system image is currently running from another terminal I have opened. Here we see that a root partition is running out of LVDB-sys1, which is our primary volume. LVDB-sys2 is the secondary root volume, which will be of the exact same size as the LVDB-sys1. So the patch manager will back up the root volume on LVDB-sys1 into LVDB-sys2 using the LVM snapshot. So in case we need to roll back due to a failure in patching, all that the patch manager will have to do at this point is to reboot and boot the system out of LVDB-sys2 partition. Coming back to the patching terminal, we see that the patch is in progress. We see that the dbnode update.sh is running, which is the real script that updates the database node. Patch manager is basically a wrapper that utilizes the dbnode update.sh on virtual servers. So at this point, we see that the backup was completed on node 1, which is basically the only node that we are running the patch manager against. So on completion of that, we see the success mentioned against it. And now the patch manager is going ahead and doing the upgrades, the operating system upgrade on the node. So this operating system upgrade would take a few minutes, after which the server will be rebooted a couple of times. During the reboot, as we saw in the cell server patching, the ILAM and the firmware on the VM will be upgraded as well. So here we see that the reboots were initiated and it was a success. It waited on the SSH connectivity. It checked for SSH connectivity to be available to Exadata 14DB03 VM04, which was a success as well. And now it completed successfully the completion step on Exadata 14DB0304. So let's take a look at how you can probably look at a console during the patching. So you can do an XM list, get the list of VMs available over there, and then run the XM console command with the ID of the VM over here, 18. And XM, with that command, you should be able to connect to the console. So this is the console of Exadata 14DB03 VM04. If for any reason you're having issues with your VM not coming up, this is how you should be able to see the console of a virtual machine running on Exadata. Coming back over here, the patching is fully completed. We have our first virtual machine patching completed at this point. The patch manager should also go ahead and bring up the grid and database for you on completion of the patching. Let's go ahead, connect to Exadata 14DB03 VM04 and check for these things. Here, I'm first looking at the image info to make sure my patching is done. The image version has changed to 20.1.0.0 as expected, and the image status is success. Here you see, because this is the VM, the node type is mentioned as guest, and the system partition, as expected, is running out of LVDB-sys1. Running image history should give us both the versions, the older one and the newer one, just like we see here. 18.1.8 was the older version, with the image mode being fresh, meaning it was the first installation, while 20.1 has an image mode patch, meaning we patched to it, and the image status is a success again. So this basically tells us that the patching of this virtual machine was a success. The final things that are left to check is whether the CRS is up and running and if the database is up and running. So looking at the CRS, the daemon was not started. So we had set this to not start automatically. So I'll go ahead and start the CRS. In the meanwhile, I'll go ahead and take a look at what the Oracle release version is. As I mentioned, we should have been at Oracle Enterprise Linux 7. So here in the release file, we see that we are at 7.8 via the ESS patch 20.1. In the meanwhile, my CRS has started. Let's take a look if the PMON process is started for the database as well. Now that I have confirmed that my CRS and PMON are running, this patching of the virtual machine is completed. Now that we have completed patching DOM-use, we need to patch the DOM0 that hosts the DOM-U. To be able to patch the DOM0, we will need to shut down the DOM-use running on them. Here, running XMList, we see that we have two virtuals, XR14 DB03 VM04 and XR14 DB03 VM01 running. We'll have to shut down the database and the CRS running on these before we shut down the hosts themselves. So let's now log in to XR14 DB03 VM04 and shut down the CRS and the database. Here you go, I'm shutting CRS down. I'll have to do the same thing on XR14 DB03 VM01 as well. Let's log in to XR14 DB03 VM01 in another terminal and shut down the database and the grid. Here I see that there are two instances of database running. I'm using CRS to shut down the databases as well. If you would prefer, you can shut down the instance yourself and then shut down CRS. So coming back to VM04, we already see that the CRS is down. So I can now go ahead and shut down the virtual using the shutdown command. Coming back to the host, I'll be now shutting down VM01 as well. So let's now take a look at this from our host or DOM0 XR14 DB03. So running XMList again, I should be able to see the status of these virtual machines. I see that the VM04 is already shut down while VM01 is about to go down. Checking again, both the VMs are already down. At this point, we should be ready to go ahead and patch the DOM0 XR14 DB03. Since any VM on a DOM0 belongs to only one VM cluster, you will be shutting down only one node of a cluster to patch a DOM0. As a result, you can perform this patching in a rolling fashion. Another important point in case, which is pretty obvious, is that you should not be running the patch manager from the same system that you are patching. So we will be patching XR14 DB03 from our DOM0 DB01, which is the first DOM0 node in this half rack. DB01 is the same node from which we patched the VM04 in the last demo. All the patches, as we saw before, are hosted within the /temp ESS20_1 folder. Let's get into that folder to take a look at all the patches over there. The patch 30259840 is the image patch that we will require to patch DOM0, which is different from the P3025821 that we use to patch the virtual server. The patch manager that we used in patching the virtual server XR14 DB03 VM04 can be used to patch the DOM0 as well. The patch manager is the same. So for patching DOM0, I'll create the DOM0_nodes and update it with XR14 DB03, the DOM0 node that I need to patch. Let's now build the patch manager command. So the patch manager command will have the DB nodes option like we provided last time, but this time we'll have the DB DOM0_nodes provided as the input. We again use the -pre-check option, and mention the ISO repo. So this is what will change. The ISO repo at this point should point to the patch P30259.840. Another important point to make is that dash or double dash with these options can be interchanged. Let me get this syntax right, and then we are ready to execute the patch manager. So we also, if you remember, we need to mention the target version to describe what target we are going to. So the target version over here, just like in patching the virtual machine, was 20.1.0.0 200016. And then we use the no modify at pre-check option. So I'm going ahead and running the pre-check over here. This will go ahead and do all the pre-check. We already see that the user equivalence and the free space is being checked. This will take some minutes for completion. So we have a failure. Let's now take a look at where and why it failed. Since we are running this only against the node exap14 db03, it obviously failed against it. If the dom0_nodes file had multiple nodes listed, it would have shown all the nodes against which it would fail. Here, I'm looking at what caused the problem. So here we look, it clearly mentions that the given to release and the found release do not match. I basically had a typo where I typed 200016 instead of 200616. Let me now correct my typo and rerun the command again. This should take a few minutes. Well, looks like we again have a failure. Let's now see what the error is this time. This time, we have a bigger problem than a typo. We have the Exadata complaining of an hardware error. As you can see, the patch manager is mentioning that you can use the ignore alerts option to continue. However, it's always advisable to fix your error than using the ignore alerts option. Let's now go back to the terminal where I have a session on DB03 from where we shut down the VMs running on it and take a look at what the error really is. So we are now on Exadata 14 DB03 DOM, which we were trying to patch. Let's now use the dbm CLI utility to check for any alert using the alert history command. I know on this server, we had a memory dim go bad recently, which was replaced. However, the alert was probably not cleared after the replacement. Running the list alert history to make sure that's what's complaining over here, we do see that the memory error is being mentioned over there. Since I know the hardware replacement was completed, I'm sure that I can go ahead and clear these alerts. You will need to examine each of these alerts and take appropriate action before you clear them. You can get the list of all the DBM CLI options using the help option. So here we see the list alert history that we used just now. So again, I list alert history to see the alerts and get the alert IDs. I will now go ahead and drop all the alerts in the history. Alerts can be dropped individually by using the drop alert history with alert number, just like I did now. You can do drop alert history with the alert ID 2_1, and it would just drop one. Or you can just do drop alert history all, and it would drop all the alerts. It's important to make sure you have acted on these alerts before dropping them. Do not ever drop them only for the sake of going ahead with the patching. So I again list alert history to make sure there are no further alerts happening. So let's now go back to our patching terminal and go ahead with the pre-check again. This should again take a few minutes to complete. So I'm executing the prereq again at this point. This should again go through all the prereqs and complete within some time. Okay, now we have a successful completion of pre-check, and we should be ready to go ahead and run the patch by itself. Let's now make the necessary changes on the patch manager syntax to change the pre-check to upgrade and remove the no modify at prereq option. As we saw when we patched the virtual, the patch manager will go ahead and rerun the pre-checks, and once passed, will go ahead with the patching. This should take about 30 to 40 minutes to complete. We will check back in time to see different status. So checking back over here, we see that the pre-check completed successfully. The root partition got backed up, the OS patch applied, and the host has already rebooted. We now have DB03 waiting to check on SSH connectivity. Okay, so now we have the DOM0 patching is completed. We did not have any issues other than those encountered during the pre-check that we took care of. We started this patching, as we see, around 7:21 a.m. and completed at 8:36. That's about 45 minutes for patching a DOM0. This is pretty normal and as expected, and this must be considered during your patch planning. If you're able to get a downtime on your Exadata frame, you can patch all DOM0 nodes parallelly after shutting down the VMs running on it. Let's now make sure everything is all right on this DOM0. For that, I log into the DB03 to check the image version that was installed. So here I run image info and find that my image version is 20.1.0.0 as expected, and the image status is a success. We also see that the node type is mentioned as DOM0. Running image history now, we see that we had 18.1.8.0 before, and we are at 21.0 now. Finally, let's make sure that the virtuals are up and running that we had shut down before the patching. So here we see both the virtuals VM01 and VM04 are up and running. So this completes the patching event on both the DOM U's and the DOM zeros. With this now, we have completed the patching of 7 storage servers, 1 virtual server, and 1 DOM0 server on this Exadata. In the interest of time, we will not be patching all the VMs or the DOM0s on this frame. A point to note that when you do a major upgrade like this by going from OEL6 to OEL7, few system parameters like timeout intervals, TLS configurations, ciphers, etc. may change. And you have to make sure to reset those parameters back to what your standards are. You can also check for the ILOM version that was upgraded by using the IPMI tool and querying the /sys/mb/bios for the version. To reiterate, we took about an hour, 45 minutes to an hour to patch each of the compute nodes, either DOM-U or DOM-0. More the number of virtuals you have, more the number of nodes that you need to patch during a patching event. This is a very important point that has to be considered when designing an Exadata solution. The higher you virtualize at the hypervisor level, more the amount of work you have during a patching event. Oracle offers other database virtualization techniques like multi-tenancy, ASM scope security, DB scope security that must be taken into consideration while designing an Exadata solution and not just try and create a bunch of VMs. In the next demo, we look to patch the InfiniBand switches. Since this is an Exadata X62 half-rack machine, we will be having InfiniBand as the internal fabric switch. With the Exadata X8M, Oracle has now moved away from InfiniBand to Rocky switches, though the patching mechanism and tool sets have remained the same. Let's take a look at some of the prerequisites for patching an InfiniBand switch. To be able to use Patch Manager as the automated tool to patch the InfiniBand switches, the minimum version of your IB switch should be 1.3.3-2. If not, you will have to use the upgrade IB switch.sh script that comes within the bundle to update each of the switch manually. The IB switches are always upgraded in a rolling fashion by the patch manager, and you do not need to mention it. Exadata usually comes with two IB switches, unless they are X3 and older, or they have been multi-racked. For a multi-rack Exadata, each rack of the Exadata will be having three IB switches. Two of them are leaf and one is a spine switch. In a configuration where we have one spine switch, the spine switch should be the one we patch first. If we do not have a spine switch and have only two leaf switches, we need to determine which of the leaf switch is the subnet manager or the master and patch that first. It's possible that in a multi-rack environment, none of the leaf switches on the rack being patched is a subnet master. Since the subnet master resides on another rack, in that case, the upgrade can be performed in any order. Let's now log in to Exadata 14DB03 again to begin our demo. Exadata 14DB03 is the same DOM0 from which we patch the cell servers. Again, there is no requirement from where the patching needs to happen, other than that you should not be on the same machine that you're patching. Let's get into our patch folder /temp ESS20_1 that we had created and look for the internal fabric patch that we downloaded. The patch bundle for both the IB and RAC key switches are the same. Let's now unzip the P302583 patch, which is our internal fabric patch that we need to apply. This will create a folder called patch_switch_20.1.0 and will host all the binaries and the patch manager tool within it. So that's the patch_switch folder that we spoke about. Getting into that, we should be able to see all the binaries and the patch manager tool within that. Let's now check how many IB switches this Exadata has. We see that we have three IB switches, XF14, SWIB1, IB2, and IB3. I will now create the IB_switch_list file with the same switch names in it, but we will need to determine the order of patching. I will now have to create a IB_switch_list file that we will use with the patch manager. This file should contain the names of all the three IB switches we just now discovered. So I put in all the three names that we just got. I want to make sure that the equivalence is set up and running. I run a DCLI using the IB switch list I created and running the command hostname against it to make sure equivalence is set up. Here I see that DCLI was able to execute the command hostname across all three IB switches, confirming equivalence is being set up and working as expected. GetMaster is another interesting command that we can use to determine who is the master switch among the IB switches. Here I'm running getMaster against all three IB switches. Looking at the output, I see that IB2 is the master switch over here, while IB1 and IB3 are standby masters. We are now ready to run our pre-check. Let's now set up the patch manager syntax to run the pre-check. The syntax basically will be similar to what we had for the cell servers. Patch manager followed by IB switches, the IB switch list file that we just created, the -- upgrade option with the IB switch pre-check option for the pre-check. Note that here you do not need to mention the rolling option, since rolling is the default and only method to patch your IB switches. Running the pre-check now, we see that it begins checking for SSH equivalence. It checks for network connectivity. Let's make sure where the subnet manager is running. So as we see over here, it determined Exadata 14 as switch IB2 to be the subnet manager, the check that we did manually a couple of minutes before. The patch manager will now go ahead and perform the entire pre-check on all three IB switches. The pre-check, as we see, also checks for available space in both /temp and the /root file system to make sure the patch can be copied to /temp and applied to the root file system. Okay, so now we have the pre-check completed. The pre-check ran against all three InfiniBand switches and completed successfully. We can now go ahead and run the actual patching event without the pre-check option. Again, no need of using the rolling option. As we have always seen, the patching event will do a pre-check again, and then once the pre-check is completed, it goes ahead and tries to patch it. It's important for the patch manager to be able to resolve the host name from which the patch manager is executed within the IB switch, and it will check for that from each of the IB switch. We will now pause the demo and come back when the patching is completed. Okay, so we completed the patching on Exa14SW IB1, but then looks like I ran into a problem where the DOM0 Exa14DB3 dropped connection to the IB server. This would have happened because we exceeded the client alive time interval that was set on DB03 on upgrade. As I mentioned before, some configuration does get changed when having major upgrades like going from OEL6 to OEL7, like we did on this Exadata 14 DB03 node from which we are patching these InfiniBand servers. Let me now log back into Exadata 14 DB03 and take a look at the SSHD config parameter. So now I'm on Exadata 14 DB03. Let me VI the SSHD config file and search for the client alive interval within that. So here I see that the client alive interval has changed to 600 seconds, which is basically 10 minutes. So we lost the SSH session from this host where we were running the patch manager from the IB to the IB switch. I will now change it to a really large value for this demo. You need to determine what your security policies state and change it accordingly. 8640 is a good accepted number in most cases. Make sure that once you make those changes, you restart your SSHD services. We can now go ahead and execute the patch manager again with the same commands. So I had a typo there, so I'm re-executing it. It will again run all the pre-checks on all the three switches as expected, and go ahead with the patching and completion. So over here, it's already begun to patch IB1, but as we already saw, IB1 is already patched to 2.2.15. It should now recognize that and go ahead to patch the remaining switches. So here we see that it recognized Exadata 14 IB1 was already at 2215_1. So it started patching IB3 server or the IB3 switch. We hope IB3 and IB2 switch will be patched successfully now without any interruption. We will give it some time to complete the patch and rejoin once the patch is completed. Here we see that both IB3 and IB2 switch have completed the patching successfully. Let's make sure of that by checking the version of the IB switch by running the commands manually. So here I again use the DCLI to run a command called version against each of the three IB switches. Here we see that the IB switch version has been upgraded to 22515-1 on all the three switches, IB1, IB2, and IB3. So this completes the entire InfiniBand patching. The entire IB patching took approximately about 75 minutes to complete, and something you need to consider when you are planning for the Exadata infrastructure patching. With this, we have now completed the entire infrastructure patching of an Exadata. Point to note is that it's basically a single command patch manager that you have to execute a few times to complete the entire patching. Though it might seem laborious, it's just one command, and the entire process becomes way quicker if you're able to obtain a downtime to patch all the components in a parallel fashion. You can also mix and match the order of the infrastructure components patch if there is a requirement for the most part. But the order we follow today is a good thumb rule to always follow. As mentioned before, we will not be covering the grid and database patching in this webinar as they're not part of the ESS patching. We hope to cover that in a separate session altogether. As a best practice, I would always recommend you to run an exact check before you begin the patching, even as part of your patch planning, and also once the patching is completed as part of your post-patching event. Now, you even have the ability to do a diff against two exact checks and see what's changed. I will not be covering that in this session. With this being a masterclass session, the expectation is you are already familiar with exact check and the diff of exact check. Okay, now that we have patched all our system, what happens if for any reason you want to roll back, say, the self-storage server patch that we applied, or the virtual server patch we applied, or even the DOM0 patch that we applied? Let's now jump into another demo to see how we can really do a rollback on some of these Exadata patches. We will first roll back a self-storage server and then a database server that we patched in this session. We again log into the same DOM0 node, Exadata 14db03, to execute the self-storage rollback. Let's get into the directory /temp ESS20.1 where we have our patches. To roll back the self-storage server, I get into the patch_20 directory that we had got by unzipping storage patch previously. As always, with all our patching events, we begin the rollback with the pre-check option. I'm now going to run the patch manager with the rollback_check_prereq option. Note that this prereq option is specific to rollback and is different from the one we used for patching. So the pre-check is executed. At this point, prereq will make sure that a rollback is possible. You can decide to either roll back all the cell servers that we have patched or only a subset of them. For that, we need to edit the cell_nodes file and have only those servers mentioned over there that we need to roll back. We now see that the rollback pre-check was completed successfully on all the cell servers. However, if I do not want to roll back on all servers and want to roll back on only on one of the cell servers, like we discussed before, I'll have to edit the cell nodes file. Here, I really do not want to roll back on all 7 servers that we patch. So I'll go ahead and change the cell nodes file to only have exa14 cell 07, the one I want to roll back. Here, I basically go and execute the rollback now without the prereq option. An important point to remember over here is that we need to provide the rolling option over here. Otherwise, the patch manager will expect that we are probably rolling back all 7 cell servers at the same time and try to go and check if the databases are shut down. And since we have not, it would fail. So we provide the rolling option when we do a rollback to say that we are going to do only 1 cell server at a time, even though we are doing only 1 cell server. As always, the pre-check will be done first when we execute the rollback. Just wanted to bring you guys back in over here, even before it was completed, to show at this point the ASM deactivation is completed and the rollback has started on the cell server. It will now go ahead and complete the rollback and reboot the server. And when it comes back, it will be booted with the ESS 18.1.8 software. Again, let's wait for the rollback to complete over here. Here we now see that the rollback was complete. It executed the post rollback plugin check and is now finishing up with the cleanup. We see that the cleanup was completed and the entire rollback process was completed successfully. Let's now run the DCLI against XSL 07 and check for the image info. Here we see that we were on 18.1.8. We went to 20.1. And now we are back to 18.1.8. The bottom piece of the information over here is basically saying that you cannot roll back to any version before this. When we were at 20.1.0, all these markers would have pointed to 18.1.8, and hence we were able to perform the rollback. This now completes the demo on how to roll back a cell server. We will now look at rolling back a compute server. Okay, now that we have rolled back a cell server, what about rolling back a database server? Let's take a look at it. Here, I'm going to roll back Exadata 14 DB03 VM04, the virtual machine that we patched earlier today. Let me get into the temp ESS20.1 folder and find the DB server patch that we had extracted with the DB server _ patch directory. So here, I should be able to find my patch manager utility that I need to execute. The options that I need to use to execute a rollback is basically DB nodes to mention the DB node file and rollback to indicate that we are performing a rollback. The DB nodes file will contain the Exadata 14 DB03 VM04 as its only entry because that's the only server we are trying to roll back. This will now, as usual, go ahead and perform the pre-check and then complete the rollback. In the interest of time, I skip performing the pre-check before executing the rollback. So here we are. We successfully completed the rollback of the virtual DB server Exa14 DB03 VM04. Let me now run the image info to make sure we are at the image as expected using the DCLI option from this DOM0 node DB03. As you notice, instead of using the -G, we can use the -C to just mention a single host and run DCLI. So here we see that we have successfully rolled back and the image version is 18.1.8.0. So let's also check the image history. So looking at image history, it clearly indicates that we were at 18.1.8, which was a fresh install. We then upgraded to 20.1.0, and then we have rolled back to 18.1.8.0, which is our current version. So image history can be very helpful in determining how the patching events have happened over a period of time on an Exadata. With this, we come to the conclusion of this masterclass on patching the Exadata infrastructure. Hope it was useful to you and you would be able to make use of it in your day-to-day operation. Again, thanks a lot for joining us today on this webinar.